Good morning everyone. Myself Nikita Mishra from Department of Chemistry, Gujarat University.
The next session is Professor Dr. Navinchandra Shimpi, Department of Chemistry, University of Mumbai. He has more than 12 years of teaching experience in academics and research. His thrust area of research includes nanomaterials and their functionalization, biodegradable polymers and rubber nanocomposites, materials for gas sensing, nanocatalysts and their application in organic transformation reactions, synthesis of carbon nanotubes and its functionalization, nanomaterials for effective degradation of dyes, synthesis of nanofibers and binary materials. He has membership with professional societies as life member of Asian Polymer Association and Indian Science Congress. He has completed 8 research projects funded by high-profile agencies and 1 project is ongoing. 15 MTech students and 7 PhD scholars have been awarded their degree under the supervision of Dr. Shimpi. Additionally, 3 have submitted their PhD thesis and 5 PhDs are ongoing. He has published more than 70 papers in international publications and 2 in national publications. He has presented 40 national and 60 international papers in different symposia and conferences. He has delivered more than 30 invited talks in conferences, workshops, and refresher courses with different subjects. Moreover, he has 2 patents granted and 2 under examination. He has organized more than 10 conferences, seminars, and courses at different levels and played a role as active member, coordinator, convener, treasurer, and secretary. Thank you.
So, good morning to one and all. Today I am going to deliver a talk on advanced nanomaterials and their applications marching towards sustainability. Myself, Professor Dr. Navinchandra Gopal Shimpi from Department of Chemistry, University of Mumbai. So, when we talk about nanomaterials, that nanomaterial size is very much important, and because of this size of that nanomaterial, their properties are changing. How these properties are changing? When we talk about nano means very dwarf. 1 nanometer is equal to 10 to the power minus 9 meter. But this definition is not sufficient or up to the mark. So actual definition of nanomaterial is at least one dimension should be in the range of 1 to 100 nanometer. Then that material we call it as a nanomaterial. So composites made from particles of nano-sized ceramics or metals smaller than 100 nanometers can suddenly become much stronger than predicted by existing material. So when material is converted into the nano size, that material becomes a very stronger one. Just say for example, when gold is converted into the nano form, it is conversion of that gold into the nano form, that is a solid, is converted into the liquid. Another example if you like to take, that is fibers. When fibers is in the nano form, that strength of the fiber becomes very higher as compared to the normal size material. For example, metal with a so-called grain size of around 10 nanometers are much as 7 times harder and tougher than their ordinary counterpart with grain size in the micrometer range. When material is converted into the nano size, following properties are getting affected. There is a change, tremendous change in the melting point, change in the boiling point, change in the band gap, optical properties are getting changed, electrical properties are getting changed, magnetic properties are getting changed. Even the structure of the material changes with respect to the size. As I mentioned that the properties are getting changed, that physical properties are getting changed. How these physical properties of the materials are getting changed? Micron size material, when converted into the nano size, its melting point goes on decreasing. How it is goes on decreasing? Because just take for example a cube of the sugar. When we dissolve that cube of the sugar, that dissolution of that cube of the sugar is very slower as compared to the nano size of that material. Nano size can easily be dissolved as compared to the micron size. So properties associated with these nanomaterials is in the two forms. Conversion of nanomaterial is taking place in two ways. That is, First is the atomic scale conversion and second is the nanoscale conversion. When we talk about the atomic scale conversion, that is, take for example, metal is converted into the nanometal. Initially, when metal is converted into nanometal, it has some oxidation state, maybe +1, +2, +3. And when that oxidation state +1, +2, +3 is converted into the nanometal, that time the oxidation state becomes a 0. That is a 0 valence state. How this is happen? That 0 valence state is unstable. And this 0 valence state is unstable, make to be stable one by encapsulating that particular material using some encapsulating agent, using some surface stabilizing agent or other materials that can make the material to a 0 valence state. That is the one, that is when it is converted into that particular form, that is the atomic scale conversion. Molecular scale conversion means what? Just take for example, calcium chloride is reacting with ammonium bicarbonate, and if the reaction is proceed under some interference with the help of some matrix mediated growth technique, the rate of reaction is getting slower down, and because of the rate of reaction is getting slower down, the size is in the form of the nano, and that reaction is form the product calcium carbonate. Whatever the formation of that particular nano material is there, that is a calcium carbonate, that is a conversion at molecular scale. These are the two ways. And the properties of material can be different at the when material is converted into the nanoscale, the properties are getting different because of two main reasons. First reason is that nanomaterials have relatively larger surface area, means as I mentioned that when material is converted into the nano size, its surface to the volume ratio goes on increasing, and when surface to volume ratio goes on increasing, that means it has a very high affinity towards the surface as compared to the mass scale or as compared to the micron size material, that is in its original form. Nanoparticles can make material more chemically reactive, but when material is not only the surface to the volume ratio is increasing, but also material becomes chemically reactive, very highly reactive, and affect their strength or electrical properties. Second reason is that quantum effect can begin to dominate the behavior of the matter at the nanoscale. Material when converted into the nano, as I mentioned, 1 to 100 nanometer is conversion to the nanoscale, that is nothing but the nanometer. One dimension should be in the range of 1 to 100 nanometer, that is nothing but the nano. But when a material comes means in between 1 to 10 nanometer, that time it is nanoscopically confined. That material is a quantum, that is called as a quantum effect. And this is the second reason. Nanoscale materials are divided into three different categories. That is a 0 dimension. When material is in 0 dimension, that is a nanodot, that time length, breadth and height are confined at a single point. When material is in 1 dimension, it has only one parameter, either length or breadth or height. For example, very thin surface coating. 2 dimension, it has only length and breadth. For example, nanowires and nanotube. 3 dimension, it has all parameters of length, breadth and height. For example, nanoparticles. This is a very beautiful slide which suggests that is a reaction of the class topper when backbenchers give the right answer. Actually, why I put this slide, because before 20 years back, that nanotechnology is sitting to the last bench and microtechnology is a top class, a class topper. But from last 20 years, when researchers feel that this microtechnology doesn't give the expected property or desired properties what we like to have, and therefore researchers have started their research towards the development of nanotechnology, development of the nanomaterials, and that backbenchers shows the right answer towards the development of the property without a very high amount of that particular material incorporation into that base material. As I don't want to go into the history of nanotechnology, because from last 20-25 years people knows about that technology, nanoscience and nanotechnology, but it is very essential to put this focus here, because in 1959 the Nobel laureate Richard Feynman has introduced that technology, but people doesn't have trust on that particular technology because its commerciability, its economical viability doesn't come into the marks, and therefore people ignore the sentence that there is a plenty of rooms at the bottom said by Nobel laureate Richard Feynman. But again, in 1970-1975, Japanese scientist Nario has developed some nanomaterial and incorporate that nanomaterial into the polyamide nanocomposite, and it shows a drastic improvement in the properties. But when commercial viability, when commercial value is been calculated, that time it found to be a very expensive one. Therefore, again the technology getting neglected. But as far as the time passes and people come to know about the commercial viability and all the parameters associated with the commercial value, people control that parameters and make that material a very advanced one. And therefore, reaction of the class topper, the reaction of the class topper here, the reaction class topper is nothing but the micro technology, and the last bencher is nothing but the nanotechnology, because it answers all the questions which are hidden, and therefore the micro technology is looking like this. This is our missile man, Dr. Bharat Ratna Dr. APJ Abdul Kalam, who always says that the best brains of the nation may found on the last benches of the classroom. Definitely this nanotechnology is showing its importance, and deliberately it shows the drastic improvement in the property, and therefore the sentence comes in a truth way. This is one professor and one scientist. He asking that, excuse me, where is the nanotechnology department? That time the scientist said, you just trod on it. Fibers is a natural. There are the two types of the fibers, natural and the synthetic. When we talk about the natural fiber, vegetables, animal, wood, mineral and biological fibers. And when we talk about the synthetic fiber, there are the semi-synthetic, synthetic carbon, metallic, silicon carbide, glass and polymer. Substance that is significantly longer than its width, means fiber is having a uniform length, but the diameter should be in the form of the micron or in the form of the nano size. Means whatever the length is there, that length is very much longer as compared to its diameter. Fibers are often used in the manufacturing of other materials. The strongest engineering material often incorporate fibers, for example carbon fiber and ultra high molecular weight polyethylene fiber. There are various fibers used because of their high strength, high capability of showing the properties enhanced as compared to the other materials, and therefore aramide fiber, Kevlar fibers are the long lasting fiber used from the very back time because of their very high. Nanofibers having large specific surface area, high porosity, small pore size, diameter range in between 50 to 100 1000 nanometer, length is in the millimeter or length is in the micron size, but whatever the diameter associated with that particular fiber, that diameter should be in the range of nanometer, then that fiber is called as a nanofiber. Various materials can be used, and their fiber can be drawn easily with the help of the different techniques. Application, when we talk about the application of nanofiber in terms of their morphology, there are the different morphologies are there. That is a porous material. When the material is a porous, that porous material can be used in the sensor. Branched means it is like a comb, that is a microreactor. Peapod like structure used in the filtration. Wire in a tube used in tissue engineering. When we talk about the multi-wall, they are used in the cell adhesion. Multi-channels in biomedical application. Energy storage, necklace like material. And when we talk catalysis, non-cylindrical material should be a non-cylindrical flat, but it is in the form of the in the form of the nanofiber. Why electrospinning? This table comprises the comparative study between the processes used presently, that is a drawing, template synthesis, phase separation, self-assembly. Electrospinning very much effective as compared to the other technique, because whatever the fiber can be drawn, that fiber comes into nano size with a very high tension, using the very high voltage parameter. By controlling the viscosity, by controlling the pressure, by controlling the drawing rate of the fiber, that fiber can be well controlled with the help of the controlling the parameters of that particular setup, and therefore this as far as concerned, there are very less limitation to this particular method. But when we talk of the advantages, very simple process, cost effective, a large variety of polymers can be electrospun, long continuous nanofibers can be produced, production of aligned nanofiber is feasible, means very multi-channel fibers can also be possible with the electrospinning technique. This is the electrospinning setup. That electrospinning setup is shown in the insert. It consists of the syringe, needle, then high voltage power supply, collector plate is there. When we talk about this particular setup, a high voltage power supply normally working in the range between 10 to 30 kilovolt, that much of voltage is required to draw the fiber. When high voltage is applied, that crocodile pin is connected to the needle, and through that needle a high voltage power supply is being given, and as the high voltage is applied to that needle, that whatever the liquid inside the syringe is being filled, that liquid becomes charged, and the electrostatic repulsion counters pass the surface tension, and the droplet is getting stretched. At a critical point, liquid erupts from the surface. If the molecular cohesion of the liquid is high, then stream breakup does not occur, and charged liquid jet is formed. A conductive substrate, normally grounded, will serve as a collector for the electrospun fiber. These are the important parameters associated with this particular setup. Solution properties. When we talk about the solution properties, as I mentioned, viscosity is one of the most important criteria. When viscosity is moderate, then aligning and drawing of the fiber is uniform without any formation of the knot. When moderate viscosity is there, it has the good elasticity. Elasticity is the property of the material which has the ability to get elongate during the drawing. Conductivity is very much important. Surface tension is one of the important parameter which turns affected by molecular weight and molecular weight distribution. Next parameter is the processing condition. In the processing condition, electrical field, flow rate, distance between the needle and the collector plate, take-up rate. These are the four parameters associated with this particular processing condition. When we talk about the third parameter, that is the ambient condition, that is the temperature, RH of the environment, type of atmosphere and atmospheric pressure. As I mentioned, the properties, different parameters are very much important. And when these parameters are being concerned, when effect of the concentration, that is effect of the concentration means the viscosity of the solution. If the viscosity of the solution, this is one example which I have put it, that is we have drawn this fiber in our laboratory, that is a PAN nanofibers are there. When concentration is 10 weight%, fiber can be drawn in between 200 to 400 nanometer. When concentration is 12 weight%, the fibers are drawn in between 700 to 800 nanometer. At 15 weight%, 1 micron size. Means from this study, it has been observed that at minimum concentration level, the size of the nanofibers is very smaller one, and if 10 weight% is found to be the best concentration for drawing of the fiber, and it has the size of the fiber is 200 to 400 meter. Effect of applied voltage. As I mentioned, the applied voltage is very much important. That is when if we draw the PAN nanofiber at different voltage, that is 15 kilovolt, 20 kilovolt and 25 kilovolt. From this study, it has been observed that 25 kilovolt is showing fiber size of 331 nanometer, a very small size at high voltage. Means very low voltage is not been sufficient. 20 kilovolt, that is a moderate voltage, that is giving 323 nanometer size of that particular nanofiber. Distance between the tip and the collector. Tip means a needle. From that needle, when the fiber is started to draw and where that fiber is being collected, that distance should be the maximum, so that the tension should be the very high. And because of the high tension, there will not be any sagging or there will not be the formation of any knot. And therefore, when the distance is 15 centimeter, fiber size is 438 nanometer, and when the distance is 20 centimeter, the fiber size is 368 nanometer. If you go again to a high distance, then there may be a breaking of the fiber. Therefore, 20 centimeter distance between the tip and the collector plate is sufficient, where the fibers are of uniform size. Now we go with the first method, that is the fabrication and characterization of PAN AGG-C3N4 hybrid nanofiber, that is a polyacrylonitrile silver graphite carbon nitrate hybrid nanofibers. Here is the method of drawing of PAN AGG-C3N4 hybrid nanocomposite. Initially we have synthesized graphite carbon nitride using urea. We have done the pyrolysis under atmospheric pressure and temperature use 550 degrees centigrade. Ambient pressure is there. There is a formation of graphitic carbon nitride. The powder is gray in color. Particular amount of bulk amount of graphite carbon nitride is being dissolved into the solution and then sonicated for uniform dispersion of that particular graphite carbon nitride into the solution. That graphite carbon nitride nanoparticle is then proceed for in situ deposition of silver nanoparticle synthesis, and that in situ gives the silver graphite carbon nitride nanoparticles. This particular nanoparticle is being dissolved in dimethyl formamide. It is not getting dissolved; it is get dispersed into the dimethyl formamide solution, and the solution of polyacrylonitrile, a moderate viscosity solution of polyacrylonitrile is then mixed and then sonicate, and then sonicated solution is then transferred into the syringe and applied the voltage, efficient voltage has been applied, and the fibers are drawing with the help of the electrospinning technique. This is the XRD and FT-IR study. XRD of pure silver graphite carbon nitride has been done, polyacrylonitrile is also been done, and then polyacrylonitrile silver graphite carbon nitride is also done. There is a combination of all the crystal planes is been observed, that is a 110, 002, 111, 200, 220, 311. That is the indication that there is a complete formation of PAN AGG-C3N4 is done. Further, we have done to verify the attachment of the functional group of that particular material into the drawing of the PAN AGG-C3N4 nanoparticle, and the presence of that functional group, that is a nitrile group is there, then 2246.5 nitrile group is there, then hydroxyl group is there, 1457 is there, means the presence of this particular functional group itself indicating the combination is of polyacrylonitrile AGG-C3N4 is there, and some peaks are go to below 500 centimeter is nothing but the inorganic material. This is the thermogravimetric analysis and scanning electron microscopy study. Thermal study showing the high thermally stable PAN AGG-C3N4 nanoparticle as compared to its polyacrylonitrile and AGG-C3N4. Here is the same study of that particular material. This AGG-C3N4 is looks like a petals like, means it is like a flex like structure, but when it is incorporated into the PAN nanofiber, they can be entrapped, they get exfoliated or embedded into the fiber structure, and uniform fiber structure is being formed along with the uniform diameter of the fiber. But at one point there is a bone like structure, that is a fiber is getting gnawed, some coupling of that particular fiber is been observed. This is because of the change in the viscosity during the drawing or during the fabrication of that particular fiber with the help of the electrospinning technique. This is the same EDS mapping of PAN AGG-C3N4 nanoparticle. Uniform level of that particular fibers are being observed with a uniform diametric size. Their XPS study is being done. XPS is self suggesting the very highly aligned nanofibers are being found by variation in the binding energy of that particular material. This is the transmission electron microscopy, where the fibers are getting AGG-C3N4 nanoparticles are getting decoration of that particular nanomaterial over the surface of the fibers are clearly been observed from that particular study. Now we have go through the application part, and this material is being used as a heterogeneous catalyst for visible light driven for the selective oxidation of styrene, CH2 bonded molecule and the benzene. This is the graphical abstract for that particular reaction, that is selective oxidation of styrene is there, then CH2 bonded molecule and benzene is there, and because of that particular fiber as a catalyst, the effectively efficient nanofiber material, they can be highly reusable, sustainable. This technology is, seems to be a very sustainable and very much adhere with the green protocol. So catalytic evaluation of PAN AGG C3N4 towards the oxidation. Here is the styrene. That reaction is proceed very easily with the help of the hydrogen peroxide in presence of catalyst, and the light is being used. Simple light is being used, and there is a formation of the products. That is there are the different product formation is taking place. That means if you look into that particular form, that is a styrene oxide. There is a first is a styrene oxide, second one is a benzaldehyde, third one is a benzoic acid, and phenyl acetaldehyde formation, that is a phenyl acetaldehyde. And these two products are having the yield very major as compared to the 2-1. If we look into that particular table, different catalysts are being tested along with different solvent conditions, and time is been taken. That is a PAN AGG C3N4 nanofibers in presence of CH3CN methyl cyanide proceeds the reaction in 16 hours, and yield is 98%. But when we look into the this one, that is the selectivity towards that styrene oxide gives 60% product as compared to the benzaldehyde, as compared to the phenyl acetaldehyde, and as compared to the benzoic acid. So more selective towards the styrene oxide. This reaction is more selective towards the styrene oxide in presence of solvent as a CH3CN, and in presence of PAN AGG C3N4 nanofiber. Catalyst screening and reaction optimization. Here we have done the screening of the catalyst and the reaction optimization we have done. We have changed the alkyl group here, R. Here that R is being changed with phenyl, R is changed with 4CH3, 4-methyl group, 4-bromide group, 4-chloride, 4-nitrogen oxide. And when we found that in every case in two alkyl groups, that is in pH, that is phenyl and methyl group, 98% yield was found, and sulfonine oxide, styrene oxide is showing 60 and 65% respectively yield as compared to the other one. So this reaction is very much selective for styrene oxide, and this reaction is found to be very selective for phenyl group and methyl group as compared to the bromide, chloride, and nitrogen oxide. Next reaction is a CH oxidation of methyl. Here methyl benzene is being taken. The same reaction condition are being used, and there is a conversion is taking place, that is a ethyl benzene, acetophenone is been there. And when we talk, that is the same condition, that is a PAN AGG C3N4 nanofibers in presence of solvent, that is a CH3CN. Time required for the reaction is 12 hours, and conversion rate is 98%. So acetophenone is 99% is there, conversion is there, 99% conversion is taking place as compared to the ethyl benzene. So these are the different reactants, their product, conversion, and their selectivity. So you found that this nanofiber, that is the PAN AGG C3N4, is found to be very much selective, and conversion rate is very high for that particular reactant. Is being used, that is CH oxide of benzene, means whatever the CH bond is there, that CH bond is undergoes oxidation with the help of, then there is a formation of phenol. So same solvent condition, the reaction time is 30 minutes, and it gives the 99% yield as compared to the other catalyst or other solvent condition. Time required is very less also. So scalability, 3 millimole of reactant in presence of catalyst PAN AGG C3N4, simple light is being used, hydrogen peroxide, solvent is used CH3CN, there is a formation of benzene alcohol, that is the phenol is converted 86%. This is how the reaction is happened. Gram scale reaction was conducted using 0.228 gram of benzene. The scale up reaction afforded the phenol with 86% yield after 10 minutes. This is the reusability study of PAN, EGG, C3 and 4. Means we have done the study in a vast way up to 8th cycle. When we found that from first cycle to the 8th cycle, there is a marginal decrease in the percent yield of the final product. But there is no any loss of the catalytic activity of that heterogeneous catalyst. That catalyst activity is remains same. Structure of that particular catalyst is remains same. Only few milligrams of that particular silver grafted carbon nitride nanoparticles are get removed from that particular surface, but maximum amount of that particular nanoparticles are adhere with the surface very effectively. And when we done the IC and AES study, that is the Ag concentration before reaction was 4.56%, but Ag concentration after the reactor is remains same, that is a 4.55% as such. Means only marginal change in the concentration is been observed. Now the next is the fabrication of copper nickel carbon nanofiber. Here is the precursor solution we have done used. Electrospinning is done with the help of this particular material, and there is a formation of PAN copper nickel copper nickel carbon nanofiber. So carbonization is been done, and because of the carbonization it is converted into the carbon fiber. This is the XRD study, and here is the ratio we have done selected, that is a carbon nanofiber, copper cuprous oxide, Cu2O carbon nanofibers, then nickel oxide carbon nanofiber, copper nickel, the combination of copper nickel carbon nanofiber, copper nickel carbon nanofibers, copper nickel carbon nanofiber from 1s21, 1s22, 2s21. This is the ratio selected for the synthesis of copper nickel carbon nanofiber. This is the XRD study, and that from the XRD study the presence of the crystal plane itself suggesting the formation of copper nickel carbon nanofiber at different concentration. These are the XPS study of all the nanomaterials we have synthesized, that is a cuprous oxide, nickel oxide, copper nickel carbon nanofiber from the ratio 1s21 to 2s21. This is the deconvoluted spectra. Deconvoluted spectra presents showing the change in the binding energies tremendously by conversion ratio with change in the ratio of the copper and nickel, and after the carbonization the effect is very much very effectively been observed in case of this particular material. This is the TDS study, and 2s21, 1s2, 1s21 is found to be thermally more stable as compared to nickel oxide and cuprous oxide carbon nanofiber and simple carbon fibers. FESEM and EDAX study. Here the morphology study itself showing the decoration of copper nickel nanofiber over the carbon nanofiber is being uniformly dispersed over that, and a very fine and very interesting morphology is being observed in case of this particular pair. This is the high resolution transmission electron microscopy, that showing that polycrystalline nature, diffraction pattern is there, and the decoration of that particular copper nickel nanomaterials are being observed over the carbon nano. Capacitor and supercapacitor application. Capacitor is nothing but previously known as a condenser, is a passive two-terminal electrical component used to store energy in its electrical field. When we talk about the supercapacitor, is an electrical capacitor having very high energy density as compared to common capacitor, that is 100 times more, also known as electrical double layer capacitor or ultra capacitor, and having range from 100 Fahrenheit to 5 kilofarad. Properties and classes of supercapacitor. These are the types of the supercapacitor. There are the two types of the supercapacitor: double layer capacitor, pseudo capacitor. And when we combine both these double layer capacitor and pseudo capacitor, it forms the hybrid capacitor. These are the properties where store high amount of energy, high capacitance, high rate of charge and discharge, little degradation over 1000 of cycle, low toxicity, high efficiency, that is 19.5% efficiency is there. We have used prepare some material, that is a copper nickel nanofiber of different ratio, 1s21, 1s22, 1s23, copper carbon nanofiber and nickel carbon nanofiber are also being used and to put for the cyclic voltammetric study. If we look into that copper nickel carbon nanofibers showing the high potential with respect to the current density, cyclic voltammetry at scan rate 5 millivolt per second inverse is burn, and means it is a very effectively change into the cyclic form, that is a reverse reaction is being very much effectively formed. And when we talk about the cyclic voltammogram of copper nickel carbon nanofiber with varying scan rate from 5 to 200 millivolts second inverse, it is more at 20 millivolts second inverse, that material is showing very much stable response towards that particular potential. Galvanic charge discharge curve, here copper nickel carbon nanofiber of 1:1 is showing the very high charge and discharge as compared to the other ratios, that is 1:2 and 2:1 compared to nickel carbon nanofiber and copper nickel carbon nanofiber. That GCD curves of copper nickel carbon nanofiber with varying current density ranging from 1 to 50 ampere per gram, that much of very high efficiency is observed. Cyclic stability and Nyquist plot, that is 1:1 is found to be a very effective one as compared to the others one. This is the tensile strength and Young's modulus. Here 4 weight% is showing high tensile strength as well as Young's modulus as compared to 0, 1, 2, 3 weight% loading of the filler. This material is having a high strength because the study, the purpose of this study is to verify the strength of that particular material, and if very high strength will be there, then that material is being a very effective supercapacitor, because high strength supercapacitor are being chosen for that particular application, and therefore mechanical property itself says suggesting that tensile strength and Young's modulus, improved tensile strength and Young's modulus shows that this material is a very effective material for the preparation of the supercapacitor. Next is the fabrication of PAN AGG hybrid nanofiber. Here graphite is being taken and humus method is being applied for the synthesis of this graphene oxide. In situ synthesis is being done for the synthesis of silver nanoparticle. That sonication is done, and because of that particular process, what happened, that silver nanoparticles are getting doped over the surface of that particular graphene sheet, and that is called as a silver grafted hybrid nanoparticles that can transfer into the solution formation with the help of dimethyl formamide and in presence of PAN nanofiber, PAN acrylonitrile viscous solution, and that combination of the solution is being made homogenized with the help of the ultrasonication technique, ultrasound cavitation technique, and then that homogeneous and uniform solution is being transferred into the syringe, and the fibers are drawn, and that fibers are called as a PAN AGG hybrid nanofibers. Characterization of these fibers, XRD and FT-IR study itself showing the formation of that particular uniform size of the nanofiber with formation of presence and formation of the presence of the crystal plane and presence of the functional group itself showing that PAN AGG nanofibers are uniformly synthesized, effectively synthesized. This is the XPS study and scanning electron microscopy study of this particular material. The binding energy is shifting very effectively with formation of convoluted and deconvoluted spectra, that is of silver 3D and silver 3D 3x2 at 36745 electron hole, 3734.3 electron hole. That is the binding energy of that particular material. And this image itself showing that very highly porous, very effective decoration of silver graphited nanoparticles over the surface of that particular PAN nanofibers with a high porosity. This is your TEM and index presence, elemental composition showing the presence of these particular elements in that particular fiber. Very high porosity, very transparent, looking to be a very transparent one. Because of the high porosity, this material is to be very effective one in various applications. Thermal stability is found to be very moderate, very impressive one as compared to the other material. This is the mechanical property, high tensile strength, 50% loading showing high tensile strength. It is more than 350 megapascal. When we talk about the elongation net break, it is more than 400 percent. And when we talk of the Young's modulus gigapascal, it is showing in between 50 to 60 gigapascal. Hardness is very high, and therefore because of the hardness, this material can be used as a reinforcing material in the polymers to improve their properties for the desired application. Now their application as a photocatalyst under solar event. Photocatalyst. What does it mean by photocatalyst? Photocatalyst is a substance uses light energy to facilitate chemical reaction, where in presence of light and water, photocatalyst creates strong oxidation agent, oxidizing agent and electronic holes to break down the organic matter to carbon dioxide and water. This picture is suggesting that copper sulfate nanoparticle used as a photocatalyst, and there is a whatever the gap between valence band and conduction band, that gap is called as a band gap. Because of the formation of the electron and the hole pair, the band gap is changing, and because of change in the band gap, this material can be acting as a good photocatalyst for the oxidation of 4-nitrophenol, and that 4-nitrophenol get degrade and oxidize to form the degradation product along with the reduction product, that is a degradation product in presence upon degradation, and that material can be easily get degraded with the help of this particular copper sulfate photocatalyst in presence of visible light. Application of the photocatalyst, it is acting as a it has the effect sterilizing effect, deodorizing effect, air purifying effect, anti-fogging, self-cleaning, water purification and dye. This is the beautiful slide where you look into that 2 billion people belonging to 60 countries of the world are dying for water, and it is being predicted that by 2050 the figure may be go up to 7 billion. Means in last 3 generations, this is the story of a crow who is very thirsty, and when to remove his thirsty, that crow found the water, and that water is very much down to the vessel so that he used to throw the number of stones into that beaker, so that the water is get lifted and he take the water. But again he doesn't find the stones, then he used the straw to take the water, and then he is very advanced that he uses the water for lifting the water, and he take the water. But if the water will not be there in the vessel, then how could we get, from where could we get the water? And we have to think more about that. And this is the examples, how could I get the water? These are the dye in the wastage from the dye industry, and because of the wastage of the dye industry, maximum water is get polluted. Very hazardous dyes are there, pigments are there, which make the water very polluted. And if very pure source of the water is less, that time we have to think to make this water purify and use that water for the drinking purpose. And therefore we have used this material for the purpose of degradation of these particular dyes inside the water. We have used the different forms of that particular material: pure PAN nanofiber, pure silver graphated nanoparticles, and PAN AGG nanofibers are being used for the degradation of methylene blue. And if you look that PAN itself showing 25% degradation of that particular methylene blue, the AGG is showing 79% degradation, but PAN AGG nanofibers showing 88.1% degradation of that particular material. And the degradation is very effective at this one, that is a 75-minute degradation is required, and that can be get degraded very fast. When we go for the photocatalytic activity of for methyl orange also showing a very good degradation for PAN AGG nanofibers at 82%. Means, and when we compare both these, that is a methylene blue is showing a very good response for the degradation in presence of PAN AGG nanofibers as compared to methyl orange. So photocatalytic activity without catalyst, there is no degradation up to 90 minutes. Without catalyst, the dye remain as such in the solution in the water, no degradation of methylene blue or no degradation of methyl orange is possible without any catalyst. This is the kinetic study of methylene blue dye and methyl orange dye. Both these showing the pseudo unimolecular first order reaction. From this kinetic study we came to know that it is a pseudo unimolecular first order. This is the degradation mechanism where the conduction band and valence band, the band gap between the conduction band and valence band seems to be very appreciable one, and mineralized product formation is taking place. This is the complete mechanism. Solar irradiation is happen, and because of the presence of silver graphited nanoparticles, the degradation rate is very impressive with electron hole pair with change in the band gap of that particular system. Reusability, with the in presence of quencher we have used different quencher we have used, and number of cyclic study we have done. That is methylene blue shows 91% degradation, while methyl orange shows 84% degradation. Very marginal decrease in the degradation rate is being observed, and even after fifth cycle that material does not lose its catalytic activity. It is very highly porous one. We have done the TOC removal study in case of methylene blue and methyl orange, that is a silver grafted. TOC removal is 75% as compared to PAN, and PAN EGG it shows 86% TOC removal, but here in methyl orange it is 80% removal of that particular TOC removal. Reusability, XRD and FESEM shows there is no change in the morphology of PAN AGG nanofibers. The activity is as such in from the first cycle to the last cycle. Only marginal change in the activity is there. There is no change in the morphology of that particular material. Even the presence of the crystal planes are remain as such. Functional group itself showing that degraded MB, degraded methyl orange, complete degradation is happen, mineralization is taking place. This is the comparative study. We have compared with the previous study. PAN AGG nanofiber methyl orange is get degraded at 75 minutes under solar light, and PAN AGG nanofiber methyl orange is get degraded at 90 minutes under solar light. When we go into the previous study, they have taken very much more time, that is a 7 hour, 5 hour, 480 minutes, 180 minutes, 170 minutes, 180 minutes, 6 hour. Very much time is required for in presence of the other nanoparticles and nanofiber, but this material is found to be very effective. I thank you for hearing me very calm and cool. I have tried my best to put all the research which we are doing in our laboratory, and I am able to present this research work because of this my student Dr. Shilpa Jain, Meenakshi Jha, Akshara Shah, Milind Tamore, Sarika Rasal, Mujahid Khan, Shabnam Khan, Jayesh Morankar, Jolina Rodriguez, Aruna Sudapalli, Jayesh Dixit and Pullikware. These people are doing very hard work in the laboratory to make me able to present the work in presence of you well-learned people. Also, I thank to HRD Gujarat University for inviting me as a resource person to deliver a talk in front of you. I will be very happy to answer your all questions. If you have any queries, please ask me on my given email ID in the first slide, or you may directly contact me on my given mobile number. So thank you much. Thank you.
Thank you very much, sir. It was very nice and informative session for all. Thank you very much once again.